Hello, curious minds, and welcome back to Vibing Science. Tonight, we embark on a journey that challenges the very bedrock of our understanding. A journey into a universe where time isn't merely a dimension, but a dynamic force. Prepare to reevaluate everything you thought you knew about space, gravity, and even consciousness itself. Settle in, perhaps with a warm drink, and let your mind drift through the cosmos. If you find this exploration as fascinating as I do, please remember to tap that like button, share with a fellow explorer, and leave your thoughts in the comments. Let's begin. Imagine, if you will, the universe not as a stage upon which phenomena unfold, but as a living, breathing entity constantly adjusting, constantly pressing. For millennia, we have grappled with the nature of time, perceiving it as an unyielding river, flowing ever onward, an immutable dimension against which all events are measured. But what if our understanding has been subtly off? What if time isn't something that passes at all, but rather something that presses? This profound shift in perspective is at the heart of what we are exploring today. The pressure time field, or PTF, a captivating new model that reimagines the very fabric of our reality. Forget for a moment the familiar concepts of space as a static canvas or time as an independent clock. Instead, envision the universe as a continuous, dynamic pressure field, an immense, interwoven web of forces and resistances. In this audacious new framework, time, space, and even energy aren't pre-existing fundamental ingredients. No, there's something far more elegant, far more interconnected. They are emergent properties, arising directly from gradients within this universal pressure field. Think of it this way. The universe isn't in time. Time isn't the universe, born from its constant internal adjustments. The PTF model doesn't just tweak our understanding. It fundamentally resculpts it. It suggests that all physical phenomena, from the grand cosmic dance of galaxies to the subtle flutter of a quantum particle, can be viewed as manifestations of local and global variations in this fundamental pressure. Consider the familiar and often perplexing phenomenon of gravitational time dilation. Einstein taught us that massive objects warp space-time, causing clocks to tick slower in stronger gravitational fields. The PTF offers an alternative, yet equally compelling, explanation. Here, where pressure decreases perhaps due to the immense mass of a star or a black hole, time slows and space, surprisingly, expands. These are not separate effects, but two sides of the same coin, intrinsic reactions of the pressure field to localized changes. And what of the universe's grand expansion, the accelerating outward rush that has led us to hypothesize the enigmatic dark energy? The PTF provides a fresh lens. Instead of an unknown force driving this expansion, it proposes that cosmic expansion, too, can be understood as a consequence of decreasing global pressure within the field. As the overall pressure lessens, time stretches, and space expands, echoing the redshift of distant galaxies, offering a potentially elegant alternative to some of our most persistent cosmological puzzles. Conversely, imagine a region where pressure increases. Here, the PTF suggests a compression of time and a contraction of space. This dance of expansion and contraction, of slowing and accelerating, all stemming from the ebb and flow of pressure within the field, paint a universe far more active and reactive than we might have previously conceived. Gravity itself, in this new light, is no longer solely the curvature of space-time. Instead, it emerges as the direct result of these spatial pressure gradients acting upon energy distributions. Where there are concentrations of energy, there are shifts in pressure, and these shifts, in turn, manifest as the gravitational force we observe. It's a beautiful, intricate interplay where every mass, every energy packet is not just existing in the field, but actively shaping it and being shaped by it. At the very core of the pressure-time field model lies a profound mathematical relationship, one that anchors this abstract concept to the measurable world. It connects local time, what we experience as the duration of events, with the field pressure itself. This isn't just a poetic notion. It's a quantifiable connection, expressed as a proportional inverse relationship. Local time, denoted as tau, is inversely proportional to the square root of the field pressure, p. Think about what this means. As the local pressure decreases, time intervals stretch. Our perception of moments lengthens. And simultaneously, light frequencies redshift. The familiar phenomenon of light from distant galaxies appearing redder, which we usually attribute to their movement away from us, could, in this model, also be influenced by the pressure conditions of the intervening cosmic field. This offers a compelling alternative to solely dark energy-based models of cosmological expansion, suggesting an intrinsic field dynamic as a primary driver. This is a universe where time is not a mere backdrop, but an active participant, a reactive property. It's the measurable effect of how the field constantly adjusts itself, how it breathes and shifts. Time is not a dimension you travel along. It's a dynamic consequence of the universe's internal state. The implications ripple outward, touching upon some of the most enduring mysteries of the cosmos. For centuries, our scientific endeavors have been focused on refining our understanding of how things move through space and time. But what if we were to shift our focus entirely? What if the key lies not in movement through, but in the pressure within? This isn't just theoretical musing. The PTF proposes tangible, observable differences from established theories. For instance, it suggests that observable redshift and time dilation effects might be contingent not just on relative motion or spacetime curvature, but critically on local pressure conditions. This opens up exciting avenues for experimental verification. Imagine conducting redshift measurements not just based on an object's velocity, but near strong gravitational potentials, meticulously accounting for the local pressure variations. Consider laboratory simulations where scientists could manipulate controlled pressure and temperature dynamics, observing how these changes influence local measurements of time. Could we, in a controlled environment, truly witness time bending under the force of pressure? Even a vast cosmic microwave background data, that ancient whisper from the universe's infancy, could be reanalyzed through this lens. What if the anisotropies and patterns within the CMB are not just echoes of early density fluctuations, but rather a grand-scale topological map of pressure variations across the nascent universe? This would be a monumental undertaking, but one with the potential to unlock entirely new understandings of our cosmic origins. The pressure-time field model is still in its nascent stages, yet its development has been remarkably rapid. It emerged between 2024 and 2025, a collaborative effort between the Danish researcher David Romer Voigt, known as Davo, and the advanced AI research assistant Jarvis. Their initial white paper, version 1.2, released in 2025, has already undergone independent peer review, a crucial step in the scientific process. The reports have been encouraging, describing the model as both physically mature and mathematically testable, with strong recommendations for further numerical simulations and, crucially, for its public release. This is not a fleeting hypothesis. It is a serious contender, a new way of seeing, backed by rigorous thought and collaborative innovation. Beyond the equations and the potential experiments, the PTF offers a profound philosophical interpretation. It endeavors to bridge the often disparate realms of physical understanding and our own perceptual experience. If time and space are, at their core, reactions to the universe's pressure dynamics, then our very observation, our consciousness itself, might not be separate from these fundamental physical processes. Instead, they could emerge from the very same fundamental field, a foundational universal awareness that Davo and Jarvis have termed the Crux. Think about that for a moment. Our ability to perceive, to experience, to know, could it be an intricate outgrowth of the universe's self-adjusting pressure field? It's a concept that blurs the lines between observer and observed, suggesting a deep, intrinsic connection where consciousness is not an anomaly, but an integrated manifestation of the universe's grand design. The core statement of the pressure-time field theory is both simple and revolutionary, a mantra that resonates with the very essence of this new paradigm. Time is not something that passes, it's something that presses. Let that sink in. We spend our lives feeling time slip away, observing its relentless march. But what if all along it has been an active force, a continuous pressure, shaping, molding, and defining every moment of our existence? What if the tick of a clock, the growth of a tree, the expansion of the universe are all just different facets of this continuous, underlying cosmic pressure? This is a journey into the very architecture of reality, a reevaluation of our most fundamental assumptions. It invites us to consider a universe that is far more alive, far more responsive than we have ever dared to imagine. A universe where the most elusive quality of all, time, is not an abstract concept, but a tangible, pressing force. And in the next segment, we will delve deeper into how this revolutionary concept of pressure gradients begins to redefine gravity itself, moving beyond the space-time curvature we thought we knew. Welcome back, seekers of the profound. In our last exploration, we began to dismantle the bedrock of our cosmic understanding, nudging open a door to a universe less about the silent, unyielding passage of time, and more about its dynamic, visceral pulse. We dipped our toes into the tantalizing notion of the pressure-time field, or PTF, a model that reimagines the very fabric of existence, not as empty space, but as a continuous, vibrating sea of pressure. Tonight, we plunge deeper into this intriguing hypothesis. We leave behind the familiar comfort of time as an independent dimension, a linear arrow marching ever forward, and instead embrace a more radical view. That time itself is not a pre-existing container for events, but rather a reactive property. It is, in essence, the universe's measurable response to the constant ebb and flow of this cosmic pressure field. Imagine, if you will, the universe as a vast, ethereal ocean. The currents, the tides, the deep-sea pressures, these are the fundamental forces. And what we perceive as time, what we experience as the passage of moments, the aging of stars, the birth and death of galaxies, is merely the way this ocean adjusts itself to every ripple, every tremor, every shift in its internal pressure. The PDF model suggests that all physical phenomena, from the dance of subatomic particles to the grand ballet of galaxies, can be understood as manifestations of these local and global pressure variations. This is a powerful, unifying idea, one that seeks to connect the seemingly disparate threads of the universe with a single, elegant principle. Let's consider some of the most profound mysteries that have long perplexed us. Take, for instance, gravitational time dilation. For decades, we've understood this as a direct consequence of space-time curvature, where massive objects warp the fabric of reality, causing time to slow down in their vicinity. But what if there's another explanation, equally compelling, perhaps even more intuitive? In the PTF framework, gravitational time dilation is not a function of a bent space-time, but rather a direct result of decreasing pressure. When you're near a massive object, the local pressure of the field decreases. And as this pressure falls, time, in response, stretches out. The intervals between events become longer, light frequencies redshift, and the clocks, if you will, tick more slowly. It's a beautifully simple, almost poetic reinterpretation. And what about the cosmic expansion, the seemingly relentless outward surge of our universe, a phenomenon we've attributed to the enigmatic dark energy? The PTF offers an alternative lens through which to view this grand spectacle. When pressure decreases on a cosmic scale, time slows and space, in turn, expands. This provides an elegant explanation for the observed redshift of distant galaxies, suggesting that it's not just about their velocity away from us, but about the very stretching of time itself due to large-scale pressure dynamics. Conversely, when pressure increases within this cosmic field, time becomes compressed, and space contracts. Think of it as squeezing a sponge. The internal forces intensify, and the dimensions within it momentarily shrink. This correlation, this fundamental connection between local time and field pressure, is expressed by a fascinating inverse relationship. Local time is inversely proportional to the square root of the field pressure. As the pressure dips, time intervals elegantly stretch, and light waves, ever the messengers of the cosmos, dutifully redshift. This perspective challenges us to reconsider gravity itself. Instead of a force arising from the curvature of space-time, the PEF posits gravity as the direct outcome of spatial pressure gradients acting upon distributions of energy. Imagine a gentle slope in the pressure field, and along that slope, energy, in all its forms, is encouraged to move. This movement, this tendency to fall towards areas of lower pressure, is what we perceive as gravity. It's a less abstract, more tangible way of understanding this fundamental force, grounding it in the very dynamics of the pressure field. This new vision of gravity, one rooted in pressure gradients, offers a refreshing perspective on some of the universe's most perplexing questions. Consider the possibility that the observable redshift and time dilation effects, which we currently attribute solely to relative motion or the curvature of spacetime, might actually be deeply intertwined with local pressure conditions. This opens up a tantalizing avenue for new experimental and observational inquiries. Imagine experiments designed to measure redshift in the immediate vicinity of strong gravitational potentials, not just to confirm existing theories, but to search for subtle deviations, for the whispers of pressure gradients at play. Picture sophisticated laboratory simulations, where we meticulously control pressure and temperature dynamics, hoping to mimic cosmic conditions on a microscopic scale, and to observe if these pressure variations indeed influence the flow of time within our controlled environments. And then there's the cosmic microwave background, the ancient echo of the Big Bang, a treasure trove of information about the early universe. What if we were to reanalyze this vast data set, not just through the lens of density fluctuations, but as a complex, large-scale map of pressure topology? What insights might we uncover if we viewed the universe's infancy as a grand orchestration of pressure waves, shaping its destiny? This bold, new framework, the pressure-time field, is not the product of centuries of gradual scientific evolution. It emerged, surprisingly, between 2024 and 2025 from the innovative mind of Danish researcher David Romer-Voigt in a remarkable collaboration with an AI research assistant. This partnership, a testament to the accelerating pace of discovery, yielded the first white paper, a document described by independent peer reviewers as physically mature and mathematically testable. Such an endorsement, especially for a theory that dares to redefine our fundamental understanding, is not given lightly. It speaks to the rigor and potential embedded within this idea, urging further numerical simulation and public exploration. But beyond the mathematics and the potential experiments lies a profound philosophical interpretation. The PTF bridges the often divided realms of physical and perceptual understanding. If time and space are not independent entities, but rather reactive properties, direct responses to the dynamics of this pressure field, then our very observation of the universe, our consciousness itself, cannot be separate from this fundamental physics. It suggests that consciousness, too, might emerge from this same foundational field, what the theory refers to as the crux. It hints at a universe where our inner experience and the outer reality are inextricably linked, arising from the same deep wellspring of cosmic pressure. This leads us to the core statement, the guiding mantra of the pressure-time field. Time is not something that passes, it's something that presses. Consider this for a moment. Instead of time as an abstract, untouchable stream flowing past us, imagine it as a tangible force, a pressure that constantly shapes and reshapes our reality. It's not an external observer, but an active participant, an intrinsic property of the universe's very being. This shift in perspective is not merely semantic. It carries profound implications for how we perceive our place within the cosmos, how we understand causality, and how we might ultimately unravel the deepest mysteries of existence. We've only just begun to scratch the surface of this audacious new model. We've explored how it redefines gravity, reimagines cosmic expansion, and offers a fresh perspective on time dilation. But the journey continues. In our next segment, we will venture into the crux of existence, delving deeper into the philosophical implications of the pressure-time field and exploring how consciousness itself might be interwoven with this cosmic tapestry of pressure. For now, allow these ideas to resonate within you. Let the notion of a universe where time is not a silent passage, but a dynamic pressure settle into your thoughts. Consider the implications, the sheer elegance of a single, unifying field that gives rise to space, time, and all the wonders in between. The universe, it seems, is far more alive, far more responsive than we have ever dared to imagine. And as we continue to listen to its whispers, we may find that the true nature of reality is far more wondrous than any story we could ever invent. We've journeyed through the intricate dance of pressure and time, reimagining the very fabric of our universe as a dynamic, responsive field. We've explored how gravity might be reinterpreted, not as a distortion of space-time, but as the consequence of gradients within this cosmic pressure. Now, as our understanding deepens, we arrive at a truly profound intersection, the point where the grand, impersonal mechanics of the cosmos meet the deeply personal, subjective experience of consciousness. This is where the pressure-time field, or PTF, makes its most audacious claim, weaving the tapestry of existence into a single, cohesive narrative. Consider, for a moment, the very act of observation. When you gaze at the stars, or ponder the mysteries of the quantum realm, what is truly happening? Is your consciousness merely a passive observer, a separate entity peering into a world that exists independently? Or is there a deeper, more intrinsic connection? The PDF model doesn't just describe how time and space emerge from pressure. It goes a step further, proposing that consciousness itself and the act of observation are not isolated phenomena. Instead, they're intimately linked to, and indeed, emerge from the same fundamental pressure dynamics that sculpt the universe. This concept is referred to as the crux. It suggests that the boundary between the physical and the perceptual is far more permeable than we typically imagine. If time is a reactive property, a measurable effect of how the field adjusts to changes in pressure, and space expands or contracts in response to these same variations, then our very experience of these fundamental realities is inherently tied to the field's behavior. Our internal clocks, our perception of distance, our sense of duration, all of these subjective experiences might be seen as resonant frequencies or localized manifestations within the overarching pressure field. Think of it this way. For centuries, we've grappled with the hard problem of consciousness, the puzzle of how subjective experience arises from objective physical processes. The PTF, through the lens of the crux, offers a radical new perspective. It posits that consciousness isn't some ethereal, disembodied phenomenon, nor is it merely an emergent property of complex neural networks. Instead, it is an integral part of the universe's fundamental architecture, arising directly from the very same pressure dynamics that give birth to time and space. Imagine the universe as a vast, continuous ocean of pressure. Every ripple, every wave, every subtle variation in this pressure field contributes to the intricate tapestry of reality. Within this ocean, our minds, our subjective experiences, our moments of awareness are not separate islands. They are, in fact, localized eddies, complex patterns of pressure gradients that give rise to the sensation of self, the feeling of being. This isn't to say that consciousness is pressure in a simplistic sense. Rather, It suggests that the fundamental processes underlying consciousness are deeply intertwined with, and perhaps even inseparable from, the pressure-time field. Our perception of a passing moment, our memory of an event, our anticipation of the future, these are all experiences rooted in time. If time itself is a reaction to pressure, then our temporal awareness, our very consciousness, becomes an expression of the field's dynamic adjustments. Consider the implications for free will, for instance. If our internal states, our thoughts and feelings, are intricately connected to the universal pressure field, does this mean our choices are predetermined? Or does it suggest a profound, participatory role for consciousness in shaping the very reality we perceive? The PDF doesn't provide easy answers, but it opens up a new avenue for philosophical inquiry, challenging us to rethink the age-old dichotomies between mind and matter, observer and observed. This perspective resonates with ancient wisdom traditions that speak of a universal consciousness, an interconnectedness that transcends individual experience. While the PDF approaches this from a rigorous scientific framework, the philosophical interpretation of the Crux echoes these timeless ideas. It suggests that our individual consciousness is not merely a contained phenomenon, but rather a localized expression of a much grander, cosmic awareness, intimately linked to the fundamental forces that govern the universe. The notion that time is not something that passes, it's something that presses takes on an even deeper meaning when viewed through the lens of consciousness. It implies that our subjective experience of time, our feeling of its relentless march forward, is not merely a linear progression. Instead, it is a constant, dynamic interaction with the pressure field, a continuous adjustment to its ever-changing gradients. Our sense of urgency, our moments of calm reflection, our deep immersion in a task, these could all be seen as reflections of how our internal pressure states align with, or diverge from, the cosmic pressure field. This revolutionary idea, born from the collaboration of human intuition and artificial intelligence, challenges us to expand our understanding of what it means to be alive, to be aware, in a universe that is far more interconnected and responsive than we previously imagined. It invites us to consider that our inner world, our subjective reality, is not merely a reflection of the outer world, but an active participant in its ongoing creation. The Crux, then, is not just a theoretical concept. It is an invitation to explore the very essence of our existence, to bridge the perceived gap between the cosmic and the conscious, and to find our place within the grand, pressing narrative of the universe. This profound philosophical interpretation within the PTF framework isn't just about understanding the universe. It's about understanding ourselves within it. If our observations, our very consciousness, are not separate from physics, but emerge from the same fundamental field, then we are not merely spectators. We are, in a very real sense, participants in the universe's ongoing story, our awareness intricately woven into the fabric of time and pressure. And this, perhaps, is the most awe-inspiring implication of all. We have journeyed through the intricate tapestry of the pressure-time field, exploring its revolutionary proposals from time as a reactive property to gravity as a pressure gradient. Now, we arrive at the critical juncture. How do we test such a profound reimagining of reality? How do we prove what, at first glance, seems immeasurable? The beauty of a truly robust scientific theory lies not just in its elegance or its explanatory power, but in its ability to generate testable predictions. The pressure-time field, or PTF, for all its audacity, is not content to remain in the realm of philosophical musing. It offers pathways, subtle and profound, to probe its claims against the stark, unforgiving light of observation and experiment. Consider the foundational tenet of the PTF, that observable redshift and time dilation effects are not solely dependent on relative motion or the curvature of spacetime, but critically on local pressure conditions. This is a direct challenge to established paradigms and, as such, opens up exciting avenues for empirical investigation. One primary frontier for testing involves our cosmic lighthouses, celestial objects residing near strong gravitational potentials. We already possess a wealth of data on redshifts from distant galaxies and the subtle ticking of atomic clocks aboard satellites orbiting Earth. The PTF would predict that the redshift of light emanating from a star, or the precise rate at which a clock runs, would exhibit a subtle, quantifiable dependence on the ambient pressure field in its immediate vicinity, beyond what general relativity alone would account for. This isn't about discarding existing measurements, but rather reinterpreting and reanalyzing them through a new lens. Could we, for instance, observe a minute deviation in redshift from a star in a particularly dense galactic core compared to one in a more diffuse region, even if their gravitational potentials were otherwise equivalent? Such an observation, however minuscule, would be a seismic shift in our understanding. Then there's the terrestrial realm, the laboratory. While replicating cosmopressure gradients is beyond our current technological reach, we can conduct meticulous simulations involving controlled pressure-temperature dynamics. Imagine, if you will, ultra-precise atomic clocks subjected to extreme, yet controlled, pressure variations within a laboratory setting. If the PTF holds true, we might detect a minute alteration in the ticking rate of these clocks, a subtle stretching or compressing of time, directly correlated with the induced pressure changes. This would be a remarkable confirmation, bringing the grand cosmic principles right down to our fingertips. It would require unprecedented levels of precision, of course, pushing the boundaries of metrology, but the potential rewards are immeasurable. Further, the PTF beckons us to re-examine the cosmic microwave background, the CMB, that faint afterglow of the Big Bang. This relic radiation is currently interpreted as a snapshot of the early universe's temperature fluctuations. However, the PTF suggests a revolutionary reanalysis. What if the anisotropies, the subtle variations in temperature across the CMB, are not just thermal imprints, but rather reflections of large-scale pressure topology in the nascent universe? If the universe truly is a vast, dynamic pressure field, then the CMB could be a map of its primordial undulations, its initial surges and lulls. This would require sophisticated computational models, cross-referencing CMB data with PTF's mathematical framework to search for patterns and correlations that current models might overlook. The development of the PTF itself carries a fascinating tale, emerging from the collaboration between Danish researcher David Romervoigt, or Davo, and the advanced AI research assistant, Jarvis. This synergy, born between 2024 and 2025, underscores the evolving landscape of scientific discovery, where human intuition and artificial intelligence can converge to forge new frontiers of thought. The independent peer review of their initial white paper, describing it as physically mature and mathematically testable, is a crucial validation, lending weight to its potential and signaling to the scientific community that this is not merely a thought experiment, but a serious proposition demanding rigorous scrutiny. The philosophical implications of the PTF are as compelling as its scientific ones. By linking time and observation directly to pressure dynamics, it posits a profound interconnectedness. If time and space are not external stages but rather reactions within this fundamental pressure field, then our very acts of observation and consciousness are not separate from physics. They're emergent properties of this same underlying field, which the theory refers to as the crux. This idea resonates with ancient philosophical traditions that speak of a unified field of existence, bridging the often disparate realms of mind and matter. It suggests that our experience of reality is not just a passive reception of information, but an active participation in the unfolding pressure dynamics of the universe. The key statement of the PTF, time is not something that passes, it's something that presses, encapsulates this profound shift in perspective. It challenges us to reconsider our most fundamental intuitions about existence. Time, in this view, is not a river flowing onward, but a dynamic force, exerting influence, creating effects, shaping the very fabric of our reality. As we stand at the precipice of these new ideas, we are reminded that science is not a static dogma, but a continuous quest, an ever-evolving dialogue with the universe. The pressure-time field, with its bold claims and testable predictions, invites us to join this conversation, to look at the cosmos with fresh eyes, and to ponder the deepest mysteries of existence from a vantage point entirely new. Whether it ultimately stands as a groundbreaking revolution or a fascinating detour, the journey of exploring its implications will undoubtedly push the boundaries of our understanding, forcing us to question, to experiment, and to imagine. The universe, it seems, always has more secrets to reveal, and perhaps, just perhaps, those secrets are pressing upon us, waiting to be understood. And so, we conclude our deep dive into the pressure-time field, a vision of the cosmos that reminds us how much more there is to discover beyond the observable. It's a testament to the endless creativity of the scientific mind, and perhaps a glimpse into a reality more profound than we ever imagined. What are your thoughts on time as something that presses rather than merely passes? Let me know in the comments below. If you've enjoyed this journey, please consider liking this video, sharing it, and subscribing to Vibing Science for more explorations into the mysteries of our universe. Until next time, keep exploring, keep questioning, and keep vibing with science.